Hello everyone, this is Amish from DigitalBrainBase.com. In today's video, we're going to be looking at what quantization means. Now, you might have heard about this term or you might have seen it pop up very often in things like Hugging Face or Ollama models. What does it mean? Well, to keep things really simple, when we train a large language model, the model starts to learn patterns and behaviors. When it starts to learn different patterns, it uses something known as weights to store that information. Now, what are weights? Weights are just numbers. And when we say something like a model has 8 billion parameters, we essentially just mean that it has 8 billion weights. Now, usually a model will have something known as FP32 or floating point 32, which means that it has 32 bits of precision. That essentially means that that weight number is going to be 2 to the power of, well, I guess not exactly 2 to the power of 32, but because we have different concepts, different ideas, but just to keep things simple, it's a really large number. All we are doing when we say use the idea of quantization is take a number that's something like 3 point blah 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 to represent a weight to just something like that, a much smaller number. Now, sure, we're still going to be losing out on some bits of information, but it's still not going to be that much of a difference. Now, in terms of overall performance, when you compare a model that's 4-bit quantized to a model that's going to be, in its full weights, obviously you might see a little bit of a performance drop. But considering that a huge amount of numbers have just been freed up, that pretty much just means that our models are going to be able to inference a lot faster. Now, let's compare to see what a quantized model performance looks like when we compare it to a non-quantized version. So here I have loaded in two models. One is the 4-bit quantization and one is the 8-bit. Let's see if we can compare the performance when we ask it to tell a story about time moving backwards. Now, as you can see here, that in terms of the overall length, the 8-bit is slightly more. I can't really compare the overall performance because I would actually have to sit and read through the entire story for both. But the start seems to be pretty much the same for both. Now, we could ask it to do a bunch of different tasks, but it doesn't really matter because even if for things like creative writing, the performance is almost going to be very, very similar. So really at the end of the day, it's going to be more of a matter of preference and also your system computational resources. If you have a small computer or a small GPU, then you might just want to use the 4-bit quantized model. If you have capabilities to host some of these really large models, then you might want to increase that quantization size to maybe 8 or 16-bit quantization. Obviously, the overall inference time is going to be a little bit lower when you use the 4-bit quantization, but the accuracy is going to be a little bit higher when you use higher floating point precision. So that's going to be your main trade-offs. And that's pretty much it for this video. If you liked it, please leave a like. If you are new to the channel, then please subscribe. If you want me to talk about other things in future videos, then please leave a comment in the comment section below and I'll make sure that those get addressed. Thanks everyone for tuning in and I'll see you in the next one. Goodbye.